Hey all! In this video, we're going to go over the elasticity of demand. So this is going to be a three-part video. Part one, we're going to define what elasticity is and go over a specific way to calculate the elasticity of demand. In part two, we're going to look at the total revenue test. And in part three, we're going to look at other elasticities. So before we start, a joke. What do you call a bee that was born in the United States? A USB.
All right, so price elasticity of demand. And so here, the good thing for us with elasticity is that it ties in with our with the past couple videos when we talked about demand and supply. Well, particularly speaking, or specifically speaking with elasticity of demand, we're looking at our demand curve. This is going to be a relatively tricky concept, right? Mainly because we're now throwing in a bit more math here. And so let's get started. So our law of demand states that there's an inverse relationship between price and quantity demanded, right? And so that is why whenever we're looking at our demand curve, our demand curve is downward sloping, right? Because here, as price goes down, our quantity demanded increases, and vice versa, right? As price increases, our quantity demanded decreases here. Why? Well, because more people want to buy an inexpensive good and less people want to buy a more expensive good here. And so all elasticity is just determining, well, how much more does our quantity demanded go up, or how much more does our quantity demanded go down, right? So it's just sort of how much. Because all the demand curve tells us is just that, well, quantity demanded, or if there's a shift, demand is going to increase or decrease. Elasticity tells us how much it's going to increase and how much it's going to decrease. So our elasticity demand, our definition is just how sensitive quantity demanded is to a change in price. Right? Because we already said that there's an inverse relationship between price and quantity demanded. So all elasticity tells us is just how sensitive, how much is our quantity demanded going to increase? How much is our quantity demanded going to decrease? So this is extremely useful, right? This is what firms do, right? So why does it matter? Well, A, it helps firms decide how much to charge for a specific product and when to have sales. Right? There's a reason why Netflix charges, right? I don't know. I'm assuming it's $7.99, right? There's a reason why Netflix charges that amount. Because they've done it and said, well, we know what the elasticity is for our good. If they charge $30 for a Netflix account, well, quantity demanded is going to decrease by a whole bunch, right? But if Netflix charges $1 per account, our quantity demanded is going to increase by a lot. So here, the elasticity of demand helped them determine how much to charge for a Netflix account here. 2, it helps them determine how many substitutes are in the market, right? If there's a lot of substitutes, you can't charge too much. However, if there's no substitutes, you can charge a lot of money for a good. And lastly, it's used by the government to help them determine how much to tax a particular product or just how much to tax in general. And so when we're talking about elasticity, and this is both for demand and supply, there are two different types. There's the inelastic demand, and then there's also elastic demand. Inelastic demand is just quantity is insensitive to a change in price. So all this is saying is that if there's a change in price, our quantity demanded is not going to change a lot, right? That if all of a sudden, right, that the price increases tenfold, people are still going to buy that product. And that's what that fourth point is. In other words, people will continue to buy the product no matter where the price is. So here, our inelastic demand curve is steep. It looks like an I. So this example right here is an example of an inelastic demand curve. Another example, it could be just a perfectly vertical line, right? This could be an extremely inelastic demand curve here. And so a good example is insulin, right? No matter what the change in price of insulin is, people need insulin to survive. So with Martin Shkreli, right, who overcharged tremendously for insulin, let's say insulin all of a sudden costs 700% more to buy, the quantity demanded is not going to change a whole lot. right? So here, the elasticity of demand for insulin is very inelastic because of the fact people still need to purchase it. So no matter what happens to the change of price, the quantity demanded might change, but just a little bit there. So in other words, the demand curve is going to look perfectly vertical or close to being perfectly vertical because people are still going to buy insulin no matter the price. Right? So what are the general characteristics? You can read it on the screen, you can pause the video, right? The important thing that I want to point out is the elasticity coefficient is less than 1. So what we're going to say, right, is that if the number is less than 1, right, whatever number is less than 1, so it could be 0.1, 0.01, 0.9, right, then it is going to be, right, inelastic. That's all it's trying to say. Okay, so if when we calculate the actual number to determine elasticity, if that number is less than 1, the good is inelastic. Well, here, if a perfectly vertical line is inelastic, then that means a perfectly horizontal line or something close to a horizontal line is going to be elastic. And so what elastic demand is just saying that a quantity is sensitive to a change in price. In other words, if there is a change in price, our quantity demanded is going to change a tremendous amount. Okay? So let's look at soda. If the price of soda increases by 100,000%, our quantity demanded is going to fall tremendously. But let's say that our price of soda decreases by 100,000%, right? Then that means our quantity demanded is going to change a whole lot. It's going to increase a whole lot here. Right? So in other words, this fourth point here, the amount people buy is very sensitive to a change in price here. And this is most goods, right? Most goods have a pretty elastic demand. Right? And so as we said, a truly elastic demand curve is flat, right? So a truly elastic demand curve is going to look like this, right? So we're going to say the flatter the demand curve, the more elastic it is. The more vertical the demand curve, the more inelastic it is here. And so yet again, you can read this, but the one I'm going to point out is the elasticity coefficient is greater than 1. So when we're calculating elasticity, if the number is greater than 1, we're going to say that that particular demand curve is elastic. Okay. All right. So real quick, is this demand curve elastic or inelastic? Well, the answer is we don't know. Right? Because it's solely based on where we are on the demand curve itself, right? So I told you guys that we could determine just sort of if a demand curve is inelastic or elastic based on how vertical, how horizontal it is. But if we're looking at one and they don't give us any information whatsoever, we can't determine whether or not it's elastic or inelastic without actual numbers, right? And so our equation to determine elasticity is this right here. A percent change in quantity over the percent change in price is going to give us the elasticity coefficient. And as we said, if the elasticity coefficient, if that number is going to be less than 1, it is inelastic. If that number is greater than 1, it is elastic there. Right? So what's the point? Well, the point is elasticity varies along the linear demand curve. So along this line, elasticity is going to vary because we said the more up, it's more elastic. The more down we are on the demand curve, it's more inelastic. It's also important to note elasticity is not slope. It is not the same thing because within the same demand curve, we can be more inelastic and more elastic here. All right. So how do we actually calculate percent change, right? Because we said to calculate our elasticity, it's the percent change in, it's going to be the percent change in quantity, right, over the percent change in price. But how do we get to percent change? Well, our equation is right here. So percent change is going to be new minus old, right, over the old number times 100. That is how we calculate percent change. New minus old over old times 100 because we're looking for a percentage here. That's why we're multiplying it by 100. So here, the next couple slides, right, is all sort of practice with calculating percent change and determining elasticity based on it. So what I would like you guys to do, if you guys don't think you have a good handle, is to practice with it. And in the comment or in the sort of the note section of the Google Slides, the answer should be there for you to check your work. And if you have any questions, just let me know and we can set up a Google Meet to talk about it a little bit later on. Right? And so here, right, the last part of our notes is just, well, what are all the different ranges here? So here we said, right, that if it is perfectly vertical, right, we are perfectly inelastic. If it is perfectly horizontal, we are perfectly elastic. And then if the elasticity coefficient, if the number of the percent change in quantity over the percent change in price is exactly 1, we're going to call that unit elastic. And then here, if it's less than 1, it's relatively inelastic, greater than 1, relatively elastic. In other words, these are the only possible numbers that we should be able to get when we plug in numbers to our price elasticity demand equation, right? Which yet again is the percent change in quantity over the percent change in price. Right? And so here, right, the elasticity demand curve should always be negative, but we don't care if the number is negative or positive. So that means we're always going to be taking the absolute value. So it doesn't matter if it's -2, right? If it's -2, that does not mean it's less than 1 because we're always taking the absolute value. So if our elasticity coefficient is -2, it is still relatively elastic because we're always going to assume it's a positive number. If it's -5, it is still relatively elastic because we're taking the absolute value of that. All right, so that's all I have for you guys today. I hope you guys learned a lot, and I'll catch you guys in the next video. Peace.